In most of the ways that I can think of, joisting the second floor is just really almost identical to joisting the ground floor. Same spacing on the joists. They feel the same. They're straight, they're long. It takes two guys to move them safely. They're real wobbly until they're braced into place, and so you don't dare get out there and walk until they're fully assembled and braced off. There's a couple of differences in the second floor joist system. The first is these are a different joist. They're manufactured by the same people, Boise Cascade, but they are a step up in terms of the strength and the stiffness of each individual joist. The top and bottom flange is wider. It's about 5/8 of an inch wider, I think, something like that. And I don't know what other magic they included in their engineering process. Maybe that's it. But what that does is it allows longer spans with the same rigidity, the same stiffness, the same immobility in the floor when you walk on it. And this is going to be, in the upstairs as in the downstairs, a very flat, very quiet, very stationary floor. And that's good, right? It feels good underfoot. And it's nice when you're downstairs that you don't hear every single footstep in the upstairs. So we're shooting for that. There's a couple of differences and similarities in the actual installation. Around the perimeter, these joists are sitting on the wall, whereas in the downstairs they were hanging from the wall. And out in the middle, we are both sitting on walls for bearing conditions and hanging from a beam with the same hangers that we used on the perimeter in the downstairs. So it's using the same sort of attachments in different places and in similar places. You have to pay attention. This is one of the things that the engineer specifies, which hangers, how many nails, and anything the engineer doesn't specify, like we mentioned earlier, is clearly laid out in the factory installation guide that you darn sure better have when you're putting one of these systems together. Now on the exterior walls of the house, these floor joists are just resting right on top of the wall itself. The rim joist is 1.5 inches wide and sits flush to the outside of the 2x6. This leaves 4 inches for the end of the joist to sit securely on top of the wall. This method is used a lot on a lot of houses on the first floor coming up out of the ground, where the floor joists sit right on top of the stem wall with a rim board around the outside. If you're new to the series, I recommend you go back and watch the episode where we were doing that on top of the foundation, because there is a lot of good information in there about floor joists and about top flange hangers and about the different ways and the different things you have to look out for when you're putting joists on a foundation that we're not going to cover here. Pretty much all of it applies to the second floor in just the same way. This board that's going up at the outside edge of this wall is known as a rim joist. It goes at the rim of the floor system, and it's doing several things. First of all, it's providing a nice, smooth, even, vertical surface to transition from the wall below to the wall above. Bearing wall below, bearing wall above, everything will be in a nice, straight, smooth line. It's providing strength at the edge for that bearing condition, because the compression on the edge of this rim joist is formidable, and this rim joist is super strong. It's stronger than the very end of individual I-joists, which could collapse if they weren't reinforced under the loads that happen at the edge of a building. It gives me a way to nail the system together. I can nail through this rim joist, down into the plate, through the rim joist, into the end of the eye joists, and then when I set the decking on top of this, I can nail the decking to the rim joist and make this whole thing an integrated, flat, tight, strong system. It's good to know that this thing's going to be in here when we put the second floor on and transfer all those roof loads down, and it goes all the way down to the foundation through this rim joist. Like the joists themselves, like everything in this floor system, this is an engineered wood product. The width and the thickness and the materials and the glue, the assembly process, everything about this board is designed and selected and run through a manufacturing process. The immediate advantage to that for me is this board is exactly the same width as the depth of these eye joists. It matches perfectly. If I was trying to use a sawn board, a naturally cut board out of a whole tree, I would have to resize it or shim it to make it match the exact depth of these eye joists. It's nice to have a fully functioning, integrated system. You may notice that the rim joist is not only used at the outside of the building. It's used anytime there's a penetration through the floor system because it defines and makes regular and nice and flat any opening in this floor system. So we're using it at the head of both the stairs, we're using it all around the boundary, and there's a couple places where we're actually using it as a small bearing member, a little beam across a short distance. It's a very handy product. Now, I'm sure I've probably said this before, but one of the downsides to using eye joists like this, and there are several downsides, is that they are kind of tough to cut. It's not like just striking a square line across a 2x12 and zipping it off. When you're marking them, you have to transfer the mark from across the depth of the flange down to the side of the web, and then back up across the depth of the flange. It's just a lot of sort of monkey motion, and cutting them is the same way. You have to lift and reposition your saw every time the table drops off of the flange you just crossed and lift it up to get onto the flange you have to cut to finish the cut. It takes a little more time, it exercises your wrist a little more, the cuts are not quite as nice. And this is especially true if and when you have to cut these things on an angle, which you will see a lot of later on in this series. The other downside, while I'm talking about it, is that you have to be careful how you fasten them. You cannot simply nail or screw them in the same way you would with a regular board. Check the installation guide. If it's not, clearly spelled out in there, call the helpline, talk to an engineer, ask him about your situation and how he recommends that you fasten it, but they are fussy about nailing through the flange because they don't want to split that thing. We're glad you're watching our series here. And before we sign out, just a couple business items. First, you all need to either subscribe to our second channel, EC2, or find our podcast, the Essential Craftsman Podcast. In these, we're sitting down in a much more open discussion type of format and reviewing and going over lots of the comments and feedback and questions and objections that surface from the viewers. And especially if you're watching the series specifically so you can learn, this is a must-have companion. I'm going to take a page out of Forrest Gump's playbook and will claim that our YouTube videos and the podcast go together like peas and carrots. Yeah, they're both all right by themselves, but together they are pretty darn good. last item, and I'm sure you know this by now, but we're sharing and will continue to share a lot of stuff, a lot of extra sort of bonus content and perks, including the cost of this project, with our supporters. And you can learn more about it at our website. In the meantime, thank you all for watching Essential Craftsman, and keep up the good work.